Well, hello. Today I'm going to show you how to implement this decision tree algorithm using Python and Jupyter Notebook. Python is the language, Jupyter Notebook is the tool, all free, no issues there. Everybody in machine learning uses Jupyter Notebook. You will see why. If you want to see how to install Jupyter Notebook or how to use it in general, please see my other videos. If you do like my videos, please like and subscribe. It really helps me out. All right, let's get going. Decision tree. First of all, in a real life situation, decision tree is super simple. You make certain checkpoints along the way um, so that these decision nodes end up giving you leaf nodes, where that leaf node means that that particular data point is now classified as something. So let's say that you're trying to classify flowers into different kinds. If you go through all the decision points based on the features, which is also called variables, you will get to the leaf node after you've taken the decisions along the way. You end up classifying that flower to be of certain type. Now, the question is, why then do we even need machine learning for this? Well, imagine if your data point has a million rows and 1,000 features, right? So your decision nodes here will be humongous. There will be way too many that is not manageable by a human. On the other hand, the machine learning algorithm does it automatically for you, which is why this becomes an active, useful algorithm to use for classifying your data. So first thing we're going to do is we're going to import some libraries. Not so important to talk about them. The data set we're using today is called Iris dataset. Some scientists back when put together different features, variables about different flowers, so that they can be classified. So we're just using that data set. So in this particular case, we're going to load the data and we're going to print the data, which you can see here. These are all the data points in different rows. Let me run those actually because I didn't run them while I'm recording. So let's run that particular cell of Jupyter. So now you can see the data set, what they look like. Each column is a feature slash column slash variable. Now we're going to take that data set and split it into two parts. There's the part that will feed it to the model and it will learn from it. And we're going to leave 20%, 0.2 here for actually testing how good our algorithm does. You would have seen this particular statement several times before in the other videos because that's how we split the data set. To repeat from the other videos, this particular variable is not required. If you set the random state to a number, then each time you run this split, it splits in exactly the same way. If you didn't have that, it would be truly random, and then your data set will vary, your accuracies will vary. Okay, so let's split the data set. That's done. Now we're going to actually call the model. It's called decision tree classifier, accurately named. Now that you've defined the model, we will actually do a fitting over the data that we've given it. 80% of the data, remember, is under X train and Y train, and we're going to use that data to fit our model using the data set. So we're going to do that right now. And now we're going to get our accuracy based on the score, which is also part of the libraries that we loaded in the very beginning of this video. So super easy. We just load the data set, split the data set, and then we run the model, fit the model, and look at the accuracy. So let's run that. And in this particular case, the accuracy is 1.0. That means every test data came out to be exactly what it's supposed to be. I don't know if I missed a step here. No, it didn't. So, okay, so yeah. So basically, to summarize, the decision tree algorithm is needed because if you have a huge data set which has lots of features, you cannot do it manually or through if then else statements in Python. You load a library that has all these models built in. You split the data, you load that model, you fit the model with 80% of the data, and then you test with the other 20% and look for accuracy. I hope you found this video useful. I will do a lot more of these for machine learning using Python. And if you do like them or if you find them useful, please like and subscribe. That really helps me. I will see you next time.